Hey guys, welcome back to another video, and in this particular video I'm going to talk about tokenization in NLP. If you are talking about NLP and the perspective of NLP, this tokenization makes a lot of sense. The reason why tokenization makes a lot of sense is because eventually we're going to go to the term called lexical analysis. So before the lexical analysis, what we do is that we try to find the tokens, right? The lexemes. To break it into lexemes, we need the tokens first. What do I mean by token and lexeme? तो बहुत easily अगर बात करें तो let's say, what should I say, if there is a thing called playing, okay, so there is a word called playing, okay. So the playing is basically what playing is a verb, right? So the playing is a verb. So this entire thing might called as a lexeme, okay. But this particular thing, if you are talking about this particular thing, so this is called a token because the token belongs to the sentence itself. So this is the reason why we called it a token. Okay, so we are learning about the tokens, okay, right? Understandable. So like we know about, if you are using ChatGPT and any kind of LLM, we understand about tokens, like we talk in usually in tokens. But this particular thing is pretty interesting because if you are talking about NLP perspective, then you need something called an idea of tokens. So there are categorization. I'm going to talk about these kind of categorizations. Firstly, there is a character level tokenization. So if you are talking about something like, let's say, I'm going to talk about some sentences, okay. So these are some sentences like the sky is blue. So how can you break it into tokens? What do you mean by tokens? Tokens are basically the smallest unit of meaning भी कह सकते हैं, but smallest unit of something which can bring an what should I say, as an input into the LLM model, or not LLM model, in a AI model, or if you are processing it, then a NLP model, okay. So into this particular thing, what we can do, we can individually break these like we can individually break these sentences, or sentences means the characters, into different what should I say, yeah, different tokens. So we can consider what happened, yeah, this S, this K, this Y, this I, this S, then this B, then L, U, E, these kind of all these things we can talk about. These are called tokens. So each character will treat as a token. So when we do these kind of things, then what we can do, what we are talking about, this is a character level tokenization. So basically, if we are talking about this, so this is a character level tokenization. So what we are doing right here, I'm going to talk about it. So यहाँ पर क्या कर रहे हैं कि हम कैरेक्टर बेसिस पे टोकनाइजेशन कर रहे हैं. सो बिकॉज वी आर डूइंग ए कैरेक्टर लेवल टोकनाइजेशन, देर इज़ अ ह्यूज पॉसिबिलिटी that it is a very small vocabulary size. Obviously we are taking the smallest units, and there is a big chance ki there is no out of vocabulary thing. What do you mean by out of vocabulary? If I type something which doesn't exist, okay, like a word that doesn't exist, something like, okay, this doesn't exist, but this can also be treated as an input, because there is no there we are using characters for tokenization, okay. So we can handle misspellings pretty easily. What is the disadvantages? मीनिंग निकालना बहुत मुश्किल हो जाता है, ठीक है. तो लाइक इट्स इज़ वेरी लॉन्ग सीक्वेंस, पहली बात तो बहुत ज़्यादा कॉस्टिंग बढ़ जाती है, ठीक है. तो सिमेंटिक लेवल पे अगर हम करना चाहते हैं, वी वांटेड टू फाइंड द मीनिंग ऑफ इट, सो इट इज़ वेरी हार्ड, ओके. ऑन द अदर हैंड, इफ़ यू आर टॉकिंग अबाउट समथिंग लाइक एन वर्ड लेवल एनकोडिंग, जहाँ पर लाइक वी आर टेकिंग एवरी वर्ड, लेट्स से द स्काई इज ब्लू. So here we are taking the entire word as a kind of token. So here the D as a token, sky is a token, is a token, and blue is a token. if we are doing this, this is called a word level to encoding. This is pretty good because the length is not that high, okay? But the issue became this have some like, not issue, this is a better way to put it, is like this helps us in semantics analysis pretty good. We can understand the meaning of the word pretty easily, okay? But there is a big issue. The big issue is that OOV, the out of vocabulary still exists, which is not a topic of conversation in character level encoding. If I type something like this has some issues because in word level encoding, we could not able to find the meaning of this because the meaning doesn't exist. There's a out of vocabulary problem, okay? Then there is a big issue is that we can't able to find something like let's say if I type something like the boy is running, so here this does not cannot able to differentiate between this and let's say the actual word called run. So this has a problem of this. So like we can't actually the morphological meaning. What do we mean by morphology? Morphology means the kind of study or language study where we differentiate the actual word with the helping verbs which are there. What should I say? Helping verbs, or I don't know, the ed, ing, which we give to the word to make it like a verb or helping verb. So that kind of a thing which we called morphology, okay? So what is the next thing? The next thing is morphology or morpheme level encoding. So what do we mean by morpheme level encoding? This particular thing it solves. Basically, if I type something like running, so the actual word is run and ing is different. So it separates it into a different token. So it reduces the like OOV problem. So if I type something like running, this still have a OOV problem in the word level encoding, but not in the morphological level or morpheme level encoding because we are separating those two things. So this is all about the encoding and stuff. In the next, we're going to talk about the level of tokenization or how can we differentiate into this. So basically in lexical analysis, what we do is that we have talked about these three things. There is three type of encodings. We use it in morphological or sorry in lexical analysis. So morphemes we talked about. Basically like if you are talking about something like if you are typing something like don't, so what should I do to make it lexically correct? To do this, we are going to differentiate or create two separate lexemes in which we put do and not separately. So to do that, what we do is that we morphologically extract them into different like words. This is also called the stemming part, okay? So like as you can talk about right here, where is it, what happened, yeah, this kind of thing you can think of, like John's book is missing from the shelf. So John's, the apostrophe s, this apostrophe s should be treated as a different morpheme or a lexeme, whatever you wanted to talk about, a token, a different token. So these kind of things can be helpful if you are doing morpheme level encoding, okay? So the next thing we're going to talk about is the methods of tokenization. What do you mean by methods of tokenization? So there are different type of tokenization methods. We already talked about these two kind of encodings. So these two kind of encodings like create the two one of the most popular ones to do like the parsing or the tokenization. If you wanted to create your own tokenizer, then one of the most two populars you could have heard of is word level tokenization and character level tokenization. So if you are talking about word level tokenization, in word level tokenization what we do, we're going to talk about in a little bit of second, but there are these kind of things. So we're going to talk about these two in a different video. In this video we're going to talk about these three, and mostly not these three, also basically these three actually: white space tokenization, rule based tokenization and statistical tokenization, and we're going to talk about also the byte pair encoding. Okay, so types of tokenization is this. If you are like separating the token in a word, so we're going to talk about, we can tell that it is a word level tokenization. If you are separating the token into characters, we can talk about this is the character level tokenization. Okay, so these kind of things we're going to talk about it more, but before that I wanted to talk more about the popular approaches of tokenization, how you tokenize. Okay, these are like what should you do on a fundamental level to tokenize, but now we are going to go into the techniques. So at first I'm going to talk about okay, right here I'm going to talk about these two things. Firstly is the white space tokenization. What do you mean by white space tokenization? If I have something like the sky is blue, what are the tokens will going to be? The tokens will going to be simply the sky is blue. So this is what we call a white space tokenization. In this kind of tokenization, we go and check if there is a white space or not. If there is a white space, we can call and we can break it into a particular token. So this is white space tokenization. Then there comes the rule based tokenizations. There is a big problem into this particular thing, which is we can't differentiate. Let's say into another, I'm going to give you another example. They don't go to class. Okay, if this is a particular thing, then what we do, if we do a white space tokenization, what we do, we separate it into this kind of thing, right? We're going to do tokenization in this particular way, but this shouldn't be optimal, because the don't, as we talked about into when we are talking about the lexeme or morphologically separating it, don't is not a word. The actual word is basically do not. So when we are doing rule level tokenization, what we do, there is an what should I say, the constants, I forgot actually, give me a particular second, I forgot the name of it. Conjugates, if I'm not wrong. So basically if you are making, or if you are talking about any conjugates, give me some time, I'm going to find the meaning of it. What does it say? Okay, punctuations, actually not conjugates, punctuations. What are punctuations? These kind of things. So the punctuation, we are differentiating whenever there is a punctuation and a white space, we are separating it based on the white space, okay, and the punctuation. So how we can do that, or what does it mean? This can help us to find a token for, let's say, hashtag NLP. If you type something like this, how can you differentiate this? This can be easily differentiatable with the use of regex, what we talked about in the previous video. And this particular thing is also comes under the part of, like, we can use the conjugate level or the punctuation level tokenization or the rule based tokenization to tokenize this particular thing. But here, what is the interesting thing is that we can tokenize this into two different parts, which is hashtag and NLP. This is the main part. So this can helps us in getting this kind of results. So this is a particular better result than this particular thing. You may ask, Mohak, why do you choose this rather than this? Because if I wanted to search NLP, so I can pretty much get it from here, not from here. This is the particular difference that we are making. So this is called the rule based tokenization. What is a statistical tokenization? Statistical tokenization is when we are tokenizing based on the statistics, whatever, like, which comes before, which comes for the most amount of time. that particular thing we are putting ahead based on the probability of the particular tokenization. Wait, give me a time. Sorry for it, I have to go somewhere. So basically what we are talking about is statistical tokenization. So statistical tokenization is when we are tokenizing one particular sentence or one particular corpus. What is called corpus is basically the sentences we are getting. So when we are tokenizing a particular corpus, what we do is that we do it in a base of statistical. What is the issue why we are not using rule based tokenization? It is pretty good, right? The issue is that what if someone is using Chinese? There is no white space at all, there is no punctuation at all, or we don't understand the punctuation, there is no space at all. We usually write Chinese in a singular manner, or Japanese, whatever you can want to talk about. This particular thing is pretty like we can understand this in English, right? But what if we are doing the Chinese parsing? Then we could not able to parse Chinese at all. NLP will not be effective in Chinese at all. So to avoid this particular thing, what we do, we tokenize based on the character level at first. So we encode it in a character level sentences. So what do we mean by character level? So what do we mean by character level is that we usually divide it in some characters. Let's say they, so we do this. So we do this, and what we do is that we find pairs which are coming up like frequently. We are tokenizing it on character level, but we are tokenizing it on base of like what pairs are coming the most. So this is the particular thing you have to understand. We're going to talk more about it in the upcoming slides or whatever you wanted to call it. So we're going to talk about byte pair encoding and these kind of stuff after this. Wait. So the next thing is byte pair encoding. What do we mean by byte pair encoding? This is the same thing which I was talking about. Let's say there is data science is a science of data. Okay, so I'm going to write it. Data science is a science of data. So what we do in byte pair encoding, we divide it in characters. So DATASCIENCE, do copy this, ISA. So I'm going to delete this data part. OF. So this is where we are dividing it into characters. After this, we're going to find the most frequent characters one by one. So at first we're going to take the first one, and I have the second one, and I'm going to pair it. So this is a new pair which is called DA, and I'm going to find DA wherever there is into the whole character sentences. So I have found DA right here. So DA became another token. Okay. The next thing, we are merging DAT, and I'm going to find DAT wherever there is. Okay, I found DAT. Next thing, I'm going to merge the A also. I found data right here. Also, I have found data right here. I have merged it. This is the particular thing I'm talking about. We can merge based on the number of time it is coming, the frequency, how it is coming. So same thing if you do this with the signs. Okay, this became another token as this exists here also. So then what are the tokens left? The tokens left is data, science, I, S, A. I might not include duplicate ones. So these are the tokens, right? So this can be easily implicable to Chinese or Japanese language also. So that is why we use byte pair encoding. you can read the same thing right here. So basically right here what we are doing, we are using this particular thing to define a sentence, a word. And what we are doing is that now all these pairs have top 2 frequencies, so we are like finding the top 2 characters of all these characters from all these characters, okay. And we are merging these top 2 characters, so we are merging the D and A, okay. So we have found this D and A merged, so we are merged the whole, in the whole sentence we are merging the D and A wherever we have found it. Corpus is nothing but a fancy name of telling it is a sentence, so it is a collection of sentences, paragraphs and these kind of things, whatever is put it as an input, okay. What is the next thing? We have found DATA, we are finding the same thing. This keep doing it until we get the maximum vocabulary size which is getting reached. Got it? So this is the byte pair encoding. Small loophole here, which is that what if some of the things doesn't actually work out, or sometimes it may work out. Like if we say playing and it is used a lot of times, but what if along with playing, imagine there is a corpus, okay, imagine there is a corpus means imagine there is a sentence, and in that sentence playing is used 4 times, studying is used 5 times, or let's say 1 time or 2 times, and running is used 1 time. So should you tell me that what might be a good way to tokenize? I can tokenize playing, studying, running differently, or what I can do, I can tokenize play, study, run, and I can separately tokenize ing for a particular purpose of, let's say I wanted to find the continuous, the sentences are continuous or not. So this might be a better meaningful way of tokenization than playing, studying, running. Every time we are storing different things, then why I'm telling you to store ing differently? Then what if play is somewhere before? What if there is a word called play? Then we have to separately store it. This has a separate meaning there. So this can be a harmful thing. Not every time, but most of the times there might be this thing exists. So what is the solution for it? We can find the frequencies, how much time it is coming. We can divide it, how much time it is individually coming. Let's say the play is, let's say, coming for 5 times. Let's say play is coming 5 times and playing is coming 4 times, and ing is coming a lot of time. Let's say ing is coming 4, 2, 1, 6 by 7. ing is coming 7 times. Now what we can do, we can actually divide this 4 by 5 into 7. So we can divide it, this is the particular thing, we can divide it and get a probability of it, okay. So this particular ratio, we can use this for, like, we can use this ratio for comparison. This particular thing is called WordPiece algorithm. This is the same thing. Here, let's say machine learning learns machine intelligence. So right here, the word in is used a lot of times, but the word in is also used individually. The I and the n are getting used individually a lot of times. So it doesn't have more presence individually than connected. But the word AR has, like, AR is used as a pair more amount of times, even though less amount of times if you are talking about in, but AR is used more meaningfully, more amount of times than in, because A and R does not existing separately into the entire sentence. Right here you can see machine learning learns machine intelligence. Here I and n, we are using a score. The score is nothing like the frequency of x and y, or basically the I and n combined, and frequency of x into frequency of y, the I and n separately. So if you find I and n, so how much times I and n exist both at the same time, like what should I say, एक साथ exist कर रहे हैं I think. So in is existing right here, 2, 3, 4. So in is existing for 4 times, and let's say find I, 1, 2, 3, 4, 5. I is existing for 4 times, n is existing for 8 times. So this has lower possibility than A and R. If you can directly run it and get the idea of what I am talking about. This is the thing what we call the WordPiece algorithm. This has more meaning. Reason why I have already talked about right here. This is the playing, studying, and this kind of example. Let's say play is already there, so it has a less ratio of coming than the studying, running, and all of the stuff. If the corpus is getting really big, WordPiece algorithm might be more optimal than byte pair encoding. Got it? So this is the stuff we have talked about in tokenization. I'm going to talk about more on the distance part, or the error correction, or let's say the spelling mistake correction into the next video. So yeah, thank you for this video.